Hey, welcome back to the lab, Virgin Media, another video, engineering. This time, I'm Steve, by the way, so this time we're doing a downstream frequency response measurement on a ONU. It's this little white box here, but instead of using the vector network analyzer, which is the top unit there, we are now using a spectrum analyzer to measure frequency response. What we've got is over on this side of the bench we have a laser. In fact, let's have a look at it. It is a AT3552H 29 laser. That laser has a signal source connected directly to the back of it. There is some attenuation there, just to get the levels correct, let the camera focus. Short lead coming up to my source, which is the Roden Swartz CLGD, which is this box here. CLGD is programmed up to deliver a full 1.2 gigahertz channel load, so let's have a quick look at that. So that consists of both DOCSIS channels and DOCSIS 3.1 channels. So what we have here is we have the first channel that's enabled, this one that's on 113 megahertz, and that goes all the way up to 1 gigahertz. Then I have a OFDM at a 1.1 gig center frequency, and on top of that we have two additional DVB-C channels at 1205 megahertz or 1.2 gigahertz. Those channels are at the top end, which makes it nice and easy for us to measure DVB-C performance. Anyway, so that's what the channel source is going into the laser. Out of the laser, we are into 25 kilometers of fibre in the box down here. Out of the fibre into a exo optical attenuator, so that guy boots up. So 5.7 dB of attenuation in there at the moment, and that's basically set up to give me approximately 0 dBm here at the input to the ONU. There is an additional exo unit here, which is a optical power meter used for measuring the light levels and what have you. Anyway, out of the ONU, what we're calling port 1, which is actually the 12 volt DC and RF power port. So out of there, into a spectrum analyzer. In this case we're using the Roden Swartz ETL spectrum analyzer. Sorry for the shaky camera. So this analyzer is multi-purpose. Basically it's a decoder as a TV decoder, as well as a spectrum analyzer or a DOCSIS stroke DVB-C decoder. So anyway, at the moment I'm in spectrum analyzer mode. I have a frequency range of 5 megahertz up to 1.3 gigahertz, and basically what I've got is I've got a lower sweep time, mainly because I've dropped the resolution bandwidth and the video bandwidth or adjusted them. So that means I'm taking approximately 52 seconds just to go across the screen, but the only reason I'm doing that is just to give me a more time to average out all the clam channels that are on there and the OFDM channel. So on the left hand side here is that 113 megahertz. In the middle here where there's a slight dip, that's 1 gigahertz. And then where marker 2 is at the top there, those are my additional DVB-C channels sitting at the top. And then that little what looks like noisy lump stuck up in the air is actually the OFDM channel, which has the same power level as the DVB-Cs. It just sticks up in the air because of the increased power for the pilots and what have you. Anyway, so that's averaged out. You can see marker 1 is set to 256 megahertz, marker 2 1.2 gig, and the difference between the two, where are we? Let's have a look. So marker 1 is 20.3 dB and the other one is around about 23 dB. So yeah, for all intents and purposes we're there or thereabouts for our requirement of 4 dB. What we do is then we measure that same thing on port 2. We measure it at 0 dBm -3 dBm and -6 dBm light levels. Just look at the response on the analyzer. Looks pretty good. It is what it is. As I adjust the light level, in fact, I'll tell you what, I should do it with the optical attenuator. Let's have a quick look. Change my step size to. Let's get it on a 1 dB step. Where are we? So this is going to step the attenuator in 1 dB steps. So as we do that, you should see the AGC adjust on the ONU. And there we go. As I say, the analyzer's on a very slow response. Sweep time. So it takes a little while to update the screen. But yeah, that's basically increased the light level by 1 dB. So I'm actually going into the ONU at +1 at the moment. Let's go the other way while it's measuring. So this is now going in at -1, and we'd give that a while just to go across the screen. But essentially, what you'll see is there shouldn't be any major gain changes there because we're within the automatic gain control range of the ONU. Just let me update the left-hand side of the screen. Nearly there, and that little step where marker 2 should disappear, and there you go, it's disappeared. Right, so while we're at it, I'll show you one of the other measurements that we do. So we drop this analyzer into decoder mode, and it's in digital TV mode. What I'm going to do is I'm going to tune it to, I'll tune it to the first channel, 113 megahertz, and just put some settings in. Oops. Just set the settings correct in here. So this is 256 QAM modulation, by the way, 6.952 megasymbols per second. So just verify that they are correct. And what I'm going to do is I'm going to optimize the analyzer attenuation. Luckily, it's got an auto function on here, so I don't have to go in there and mess about with with all the manual settings. Sometimes it works, sometimes it doesn't, but yeah, it looks like it's gone for it. So yep, so there we are. So we have a level coming out of this guy at the moment at the top, signal level of 8.4 dB, MER is 40 dB, and there's our bit error rate counters down there. That will continue to count away for as long as I leave it. Normally what we do in the lab here for general testing is we do 100 samples of bit error rate, but there are occasions where we will leave it for much longer. In fact, some of the tests that we've done, we've left it for even 24 hours just to see what will happen, particularly if it's a modulator or something like that. Let's try one of the top end channels. In fact, I think 1.213, I think off the top of my head, is the very last QAM that we have on the test setup. And yes, it is. There we go. So the very last channel, right at the top of the spectrum. We actually had the software modified in the analyzer to be able to measure this channel, because it's not normal to transmit DVB-C at 1.2 gigahertz. But anyway, there you go. Tuned to 1.2 gigahertz DVB-C. Level at the top end is just under 14 dB, 13.7. MER 41 dB, and yeah, once again error free. So yeah, really happy with that. So 2 methods of measuring frequency response. Previous video was using a vector network analyzer in S21 test, and this one's using a spectrum analyzer with a real signal source. Hope you enjoyed that. Catch you soon. Cheers. Bye bye.